One scientific process for growing diamonds in a lab is chemical vapor deposition. Chemical vapor deposition, CVD, is a technique by which diamonds can be grown from a hydrocarbon gas mixture. In the CVD process, a thin slice of diamond seed is placed in a sealed chamber and heated to around 1,650 degrees Fahrenheit. The chamber is then filled with a carbon-rich gas, usually methane, along with other gases. Then, the gases are ionized into plasma using microwaves, lasers, and other techniques. The ionization breaks the molecular bonds in the gases, and the pure carbon adheres to the diamond seed and slowly builds up into a crystal, atom by atom, layer by layer. CVD diamonds can be grown over larger areas by starting with a larger diamond seed plate. CVD process allows for a finer control over the environment in the growth chamber, and thus the properties of the finished diamond. The second scientific process for growing diamonds in a lab is high pressure, high temperature. High pressure, high temperature, HPHT method, replicates the natural process of diamond formation under the Earth's crust like a giant pressure cooker. The machines used can build up to the pressure of almost 60,000 atmospheres and to the temperature of 4,500 degrees Fahrenheit. The growth cell contains all the elements needed to grow a diamond, including a seed, highly refined graphite, and a catalyst mixture consisting of metals and powders. The entire HPHT growing process requires an incredibly controlled environment to produce a gem-quality diamond. Any shift or change during growth can cause the diamond to stop growing or can create inclusions that result in unusable diamonds. Every diamond must complete the entire growth cycle before the machine can be opened. It's only after the HPHT chamber is opened that we can see the finished rough diamond and its color, clarity, and size.